This is the 1.4 problem set, and just looking over here at what you're doing, 3 through 10, they give you identities, or they asking you to use identities to find the function value, rationalize the denominators, meaning get the radical sign out of the denominators. But in these particular ones, we're going to take the cosine of theta and find it if we know the secant of theta is negative 2.5. Alright, so if the cosecant, or if the secant of theta is negative 2.5, we need to find out what the cosine is. And what do we know about secant and cosine? They're reciprocals of each other. So the cosine of theta, if you look back in the reading here to page 27, we've got our identities. The cosine is 1 over the secant of theta. Well, we know the secant of theta, they gave that to us as negative 2.5. So, just go ahead and give me that for an answer. In fact, yeah, negative 2.5 I think will be just fine for an answer for that. So you're just using some of these identities earlier in the book in order to solve these. Jump down to 15 through 20. Find the tangent of each angle. So if you look at number 16, they give us the cotangent of theta equals 2. They want to find the tangent. Well, I know that the tangent of theta is 1 over the cotangent of theta, right? From, where is that? Back on page 27. So they told me that cotangent is 2, so tangent of theta is 1 over 2, so it's just 1/2. Okay, so not really too much there. 21 to 24. They're asking you to find the value of each variable. This is the variable. Theta is the variable. It's an angle. So you're trying to find out what that angle is. Okay, so look what we've got. We know that the tangent from the book of theta is equal to that. So in other words, the tangent of an angle is equal to 1 over the cotangent of an angle. So that means this theta and this theta are equal, right? So that equals that. So we subtract 3 theta from both sides. Because the theta, all it is a variable. It's your x value. So don't get too concerned about that. So we're going to add 8. Add 8, so we have 4 equals 2 theta, therefore theta equals 2. So this angle here that we're talking about is 2 times 3 is 6 minus 4 is 2. 5 times 2 is 10 minus 8 is 2. So it worked. So where our angle that we're looking for is a 2-degree angle. Jump down to 27 through 32. Identify the quadrant or quadrants to make that true. So they want to know what quadrant, 1, 2, 3, or 4, those trig functions are going to be in. When sine of theta is greater than 0 and the cosine of theta is less than 0. So what quadrant is the sign greater than 0? Well, if you use the all students take calculus, sign is positive in that quadrant. So quadrant 2 would be the answer for that. And the cosine of theta in that quadrant is negative because the only ones that are positive in the second quadrant are is sine and secant. Or I'm sorry, sine and cosecant. We look at the next one, 29. tangent is greater than 0. Well, tangent is greater than 0 in the third quadrant. There you go. That's all they want you to do is tell what quadrant they are in, that they're following those rules. Numbers 33 through 40, they just want to know is the sign of that positive or negative. So if we've got a 74-degree angle, 74-degree angles in the first quadrant because it's between 0 and 90. So is the sign positive in this quadrant? Yes, everything is positive in that quadrant. So sine is positive, cosine is positive, tangent. When we jump to, let's say, number 39, negative 82 degrees. Well, negative 82 means we start here like we do everything else, but we go this way. So we're in the third quadrant. Is the sine, cosine, or tangent positive or negative in the third quadrant? All students take calculus. Cosine is positive in the third quadrant. Tangent and sine are not. So that's all they're asking you to do there. 41 to 46 are asking you which one is greater, the sine of 33 or the secant of 33. And you can go back to, let's see, page number 29, ranges of trig functions, and see which one is going to give you a bigger answer. 47 to 54 is very similar to 41 to 46. You use that ranges of trig functions to find out if those are possible. And 55 to 62, you are using identities to find each function value. Use a calculator in exercises 61 and 62. So you can look back on examples 4 to 6 to see how to do those. So all they're asking you to do, if we were to look at 56, is they want you to find the sine of theta. If the cosine of theta is negative 1/4. And we're in which quadrant? The second quadrant. So there's our line. We draw that. And cosine, we know, is x over r. So we know that this is negative 1 and this is 4. So we need to find our y value here. So negative 1 squared plus y squared equals 4 squared. So 1 plus y squared equals 16. Y squared equals 15. Y equals the square root of 15. So instead of a y there, we're going to put the square root of 15. So let's erase all this stuff. And let's do y equals square root of 15, x equals negative 1, r equals 4. So the sine of theta is y over r. So our y is the square root of 15, our r value is 4, and that is the sine of theta, what we are looking for that problem. Which one did I just do? 56. All right, so 64 to 71, find all trig function values for each angle. So that's basically the same thing we did for 55 to 62, only you're finding all of the trig functions rather than just the one like we did here. We just found the sine here, but they want you to find all of the trig functions. So they gave you 64. The cosine of theta is negative 3/5, but they want you to find the sine, tangent, cotangent, secant, and cosecant, so the other 5. Okay, so that's it for 1.4.